Okay, so now we've got, what we're going to do is multiply both sides by 3. So we get 2x plus 3 is less than or equal to 3x minus 15. Then I will subtract 3x from both sides, subtract 3 from both sides to get negative x less than or equal to negative 18. And then I will divide both sides by a negative, which changes this sign, turns it around, so we get x greater than or equal to 18. So in interval notation, x is an element of square bracket, and square bracket because it's less or greater than or equal to, it's the equal to part that gives us the square bracket, 18 to infinity, and infinity has a round bracket because infinity is not an actual number, and so it just goes on forever and ever. So I'm going to test x equals 20 because that is greater than 18, and just keep things simple for myself. We could use 18.1 if you wished, or 19 or whatever, but 20 sounds good. Separate left side and right side. So left side equals 2x plus 3 over 3. The right side is x minus 5. Substitute into 20 on both sides. 40 plus 3 over 3 is 43 over 3. And 20 minus 5 is 15. So if we were to divide this, we would see that 43 thirds is less than or equal to 15. And if that's the case, then that means that the left side is indeed less than or equal to the right side. Therefore, x equals 20 satisfies the inequality. Therefore, this interval notation does check out. Okay, moving right along now. We're going to do the same kind of thing. Now we have double, I line this up here. We've got double inequalities. We're going to need to isolate for x again in the middle term. And by doing that, we're going to find the range of values that will satisfy this inequality at the moment here. And when you do any sort of rearranging of formulas, when it's an inequality, a double inequality like this, it's just the same thing. You just do the same thing to all three parts. And there's nothing really magical about that at all. So I've got 2x plus 5. I want just x remaining in the middle term. So I'm first going to see that, identify the positive 5 here, and I'm going to subtract 5 from all three parts to leave me with 3 minus 5 less than or equal to 2x less than or equal to 17 minus 5, which gives me negative 2 less than or equal to 2x less than or equal to 12. Then we got 2 times x in the middle, but we don't want 2x, we want just x. So I'm going to divide all three parts by 2 to get negative 1 less than or equal to x less than or equal to 6. And then show this on a number line. Well, we know that if we look at the left side of this, that negative 1 is less than or equal to x, which means x is greater than or equal to 1, greater than or equal to negative 1. And so that means it's going to be to the right of negative 1 on a number line. When we check out the right side of this, it says that x is less than or equal to 6, so it's going to be to the left of 6 on a number line. So it's going to be to the right of negative 1 and to the left of 6, and if we line it up in order from negative to positive, we will see that we mark our 0, negative 1 and positive 6. X is between negative 1 and 6, and because it's less than or equal to, the equal to part dictates that we will put solid circles on negative 1 and 6 because negative 1 and 6 are both included in the solution. So this next one is a slight bit more challenging, but it's pretty much the same thing. Expand out the middle term and then just do the same thing, do the same process to all three parts to isolate for x in the middle. So please work on that and come back to check your solution. Okay, so I'll expand out the middle part, so we get 6x plus 12 minus 2x minus 2, and then I'll simplify the middle even further. So we get 6x minus 2x is 4x, 12 minus 2 is 10, and now I'll just start working on isolating the x here. So because I have plus 10, I'm going to subtract 10 from all three terms. So 30 minus 10 is 20, 46 minus 10 is 36, and we're left with 4x here in the middle. And then, because that's 4 times x, I'm going to divide all three terms by 4. So 5 is less than or equal to x is less than or equal to 9. So which means that basically x is between 5 and 9. Now if we examine just the left hand side here, 5 is less than or equal to x, which means that x must be greater than or equal to 5. So x, all the x values that satisfy this will be to the right of 5 on the number line. And when we examine the right side of this, x is less than or equal to 9, which means that all the x values that satisfy this double inequality will be to the right, to the left of 9. So basically between 5 and 9, and including 5 and 9 because of the equal to part of the inequality. So it'll look like this: two solid circles, 1 and 5, 1 and 9, and the line between 5 and 9. Okay, moving on to the next example here, the very last one of today. We're asked to see if x equals 2 belongs to this, or is part of the solution set for this inequality. So basically all you really need to do is substitute in 2 into this and see if it works out. So we'll again separate left side and right side. So the left side is for quantity 3x minus 5. Substitute in the 2. Work out the brackets. We get 6 minus 5, which is 1. 4 times 1 is 4. Then we check out the right side. So we see that if we look at this here, right side is 6x, substitute in the 2, so we get 12. 4 is less than or equal to 12, which gives us the left side is less than or equal to the right side, which is not the same as what we're initially given. We're given greater than or equal to. Therefore x equals 2 does not satisfy the inequality. Okay, so what I'd like you to do now, even though we have verified that x equals 2 is not contained in the solution set, what I'd like you to do is I'd like you to work through this algebraically to see what range of values would be included in the solution set. Okay, so pause the video now please and work through that, and come back in a minute to test or check your solution. So we've got this inequality here. I will expand through the brackets on the left. So you get 12x minus 20 greater than or equal to 6x. Subtract 6x from both sides, add 20 to both sides, so we're left with 6x greater than or equal to 20. And then I'll divide both sides by 6, and then simplify, so we get 10 thirds. And greater than or equal to 10 thirds, so x is 10 thirds is 3 and a third. So x is greater than or equal to 3 and a third. And 2 is not greater than 3 and a third. It's not in that range of x values. So that further proves that x equals 2 will not satisfy the inequality. Okay, so that's your work for today. Please work on the first couple questions, 2 or 3 questions, and then come to class and work on the rest of them tomorrow morning. Thank you for your attention, and we'll see you in class.